Good morning, good afternoon, good evening. Today I'll be showing you how to make this formation text effect. Small letters placed randomly will come together to form a larger text. The concept is not difficult, but it is a comical effect, fun to watch. Alright, let's get into it. As soon as we enter Blender, we'll hop right into Geometry Nodes Layout. H to select all, X to delete. Shift A, add mesh plane. Using numpad 7 and 5, go into top ortho view, new to add a map, delete group input, and replace it with string input. Today, we'll start with single letter, so enter uppercase P. Pass it through strings to curve, then output. I'll also set the font from the beginning. No need to match it, but I'll go with this Bauhaus 93 regular font. So, this formation text effect is going to have multiple small letters in random location, which at a certain timing will come together to form a large text. Something like this. Alright, let's get started. Start off by realizing the text. Now, we'll want to make a grid to instance small characters. So, connect the bounding box after realize. Using vector mass subtract min from max. Then, separate XYZ. Connect X socket to grid size X, and do the same for Y as well. We now have a grid of text size, so let's set a resolution and calculate vertex counts. Branch a vector mass divide from subtract, and add a value node to set the resolution. Enter 0.04 and use it to divide the subtract result. Insert a vector mass add and add 1 to all directions. Then separate XYZ the result. Use the X and Y as grid vertex counts. We should end up with grid divided up to roughly 0.04 meter squares. Next, we'll set the position to overlap text. Ctrl-Shift-D this vector mass subtract, change the operation to add. Then, vector mass scale the add result. Scale it by 0.5 to determine the center position. Insert a transform geometry after grid. Then, use the scale result as translation. Now grid should be perfectly overlapping the text. We can now instance small p's to form a large P. Start by inserting an instance on points. Then branch a fill curve from realize to convert to mesh. Pick whichever fill type you want. It should not matter. Pass it through raycast and connect the isHit result to instance on points selection. We'll also use the fill result as instance. As you can see, they are too large, so let's use this value node to add scale. Now it's too small, so let's actually multiply by 2 to increase its size. Now the size should look decent. Now that we're done with single character, we'll loop this process for multiple text. Add some space before realize. Then, add a for each element node. Set the domain to instance, then reconnect. Input side comes here, and output should come after instance on points. Make sure to use the bottom socket as output. Now that we can use multiple letters, let's go back and change the original string. This can be anything. I'll just set this to pi-min, and there's no deep meaning behind it. Now, we have multiple large letters consisting of small letters of that same alphabet. This is actually going to be the final position of the animation. For the initial position, we want these letters to be scattered randomly in certain range. I want this scatter range to be based on the original text box size, so I'll restrict it by using a bounding box. So let's add a set position after for each element output. Then, branch a realized instance from strings to curve, and connect the bounding box. This bounding box should be covering the entirety of the text. Connect a random value min from bounding box min, and do the same for max as well. Plug this into setPosition socket. This will place all the small letter instances on random locations. Let's insert a mix node and connect random result to A. Then, position node to B. We can now change the letter position from initial to final by adjusting the mix factor. We can now turn this into animation. Connect the factor to map range and drive the map range value with scene time. The from min and max represents the timing that transition happens, so I'll set it so the movement occurs between 2-second mark and 4-second mark. I'll also cut the end frame to 144 so the animation ends in 6 seconds. When we play the animation, we can see the transition happening between 2 to 4 seconds. Since this movement is not that interesting, let's spike it up a bit. First, we'll add some change of pace to its transition. Add a float curve after the map range. Then, shape the curve like so. Now they should start off fast and slow down at the end like they're settling down. Next, let's make the movement less linear. Currently, instances are moving from initial to final position in a straight line. Let's add a noise texture to give some variation. Connect the vector mass scale from color, and recenter its coordinate by subtracting 0.5. Then, vector mass multiplied by 1, 1, 0 to constrain its movement to XY axes. Lastly, connect a vector mass scale and plug it into setPosition offset. We have now noise added to its position, but we want it only affecting while it's in motion. So, branch a float curve from this map range, and adjust the curve so noise influence becomes bigger in the middle. Connect this to scale. Now noise should only be affecting transition, as if they're taking a detour before reaching destination. Now let's add some more organic movement. All the letters are currently static while not in transition. We'll make them wiggle to make them look alive. Add a translate instance and a noise texture. Change the dimension to 4D and up the scale to 200. Then, insert a scene time and mass multiply. Use a value of 0.01 and plug into noise W socket. Just as before, subtract by 0.5 to center it, and multiply by 1, 1, 0 to restrict its axes. Lastly, connect the noise output to translate. If we hit play, all letters will be wiggling like microorganism. We have an issue though, as they seem to wiggle excessively while they're transitioning. This is due to the noise texture referencing current position, though the vector input is empty. It's analogous to position node being connected. Because the input position is dynamically changing by the set position, noise reference is being affected. We can connect the initial position instead to vector, so reference vector is unchanged. Now the wiggling motion should be more stable. Last thing I want to do is add an extra movement ahead of transition. Currently, how they start moving looks a bit abrupt. So let's add some animation to make it look like they're startled before they go into formation. Add a translate instance. Then, combine XYZ from translation input. Float curve from Y input. Map range from value input. And lastly, scene time to drive the map range. I want to activate this motion before the main movement. So we'll set the timing to be just ahead of front min of the main motion. That transition happens at 2-second mark, so let's set this one to be between 1.5 second and 2 second. I'll shape the curve like this, so they look like they jump up and down twice. Make 2 peaks like so. When we hit play, they should hop up as if startled, and then move to their final position. And this is their final animation. Now that we are done with animation, we'll finish off by adding some simple material. We can make them all uniform color, but I'm going to assign different color per character to make it colorful. To do so, make some space before the for each element output and insert a store named attribute. Change the domain to instance and call it hue. Next, branch out a domain size from strings to curve and change component to instance. Connect the mask divide from for each element iteration and divide it by instance count. Store the division result as hue. Go all the way to the end of the node tree and insert a set material. We'll just use the default material. Split open a new window to access the shader editor. From drop-down, we'll select the default material. Then, delete the principal BSDF. Add an attribute node to access a stored hue. And make sure to change the type to instancer. Connect factor to hue input of HSV node. And specify color of your choice. Then connect to surface output. Now all the letters should have different color assigned. Initially, all the letters are placed randomly with intermingling colors. But as they settle to their final position, all the color also gets sorted out. Alright, that's it for today. So let's go over the nodes. It's an elongated node tree, but here it is. Let's now take a look from the left. That is it, formation text effect. As you might have noticed, I got my inspiration from little creatures of a certain video game. It might not be that useful, but it is one of those that is fun to watch. Thank you for watching, and see you in the next one.